जिसमें हम है घर पर हमारा।
Hello students, I am Priyanjali Mukherjee, Assistant Professor of Electrical Engineering Department of Narula Institute of Technology. In today's video, we will discuss on the AC transients and the transient response of RL, RC and RLC circuit with the AC excitation, the examples. So let's start. What is a transient? If a circuit consists a resistor, capacitor or inductor and a supply voltage is given to it, then it will have some response. And due to sudden change or the application of voltage and current, the response of circuit will vary from the previous one. And this variation of the response of the circuit containing the resistor, inductor and the capacitor is known as the transient. And transient response occurs for a very short period of time, and after the transient the current and voltage returns to its steady state condition. So from this graph we can say that the overall response has two regions. One is the transient response, another is the steady state response. And after this transient response, the minimum time required to complete this transient response, that means after this transient time it switches over to the another state, that is the steady state. And overall response is the summation of the transient response and the steady state response. So next consider a RL circuit which is connected across the AC excitation. Here the series R and L is connected across this supply voltage. This is AC supply voltage and B is given as Vmax sin omega t plus phi, where phi is varying from 0 to 2 pi, is connected across this R and L through this switch, and this switch is considered to be closed at t is equal to 0 seconds. So at t is equal to 0 seconds, when the switch is closed, then we can apply the KVL within this loop. Whereas the drop across the resistor is VR and the drop across the inductor is VL. So if we apply the KVL, we can write the equation Ri plus L di dt equal to Vmax sin omega t plus phi. Or dividing both sides by L, that is equal to R by L phi plus di dt into Vm sin omega t plus phi. Now the P represents the vast derivative of I. So the P plus R by L into I is equal to Vm by L sin omega t plus phi. Now the current response is equal to the IC plus IP, whereas the IP is the force response and IC part is the complementary function, whereas this IP is actually the steady state response and IC is the transient response part of the system. Now IP is considered to be A sin omega t, A cos omega t plus phi plus B sin omega t plus phi. Now the derivative of this becomes minus of A omega sin omega t plus phi plus B omega cos omega t plus phi. So we can put these equations into this equation P plus R by L and phi equal to Vm by L sin omega t plus phi. So this equation is obtained and we can compare the like terms of the left hand side to the right hand side, and then we can find the value of A and B. And the expression of A is minus omega L into Vm by R square plus L square omega square, whereas the expression of B becomes R into Vm by R square plus L square omega square. So now we can put this value of A and B into the equation P plus R by L into I equal to Vm by L into sin omega t plus phi. So from this, you can write the IP equal to Km by root over of r square plus L square omega square into minus of omega L cos omega t plus phi plus r into sine omega t plus phi. Now we can choose that this omega L is equal to sine theta, whereas this r is equal to cos theta. So if it is, then the tan theta is the ratio of omega into L, that is sine divided by the r, and theta equal to tan inverse omega into L divided by r. So the IP becomes Vm by root over of r square plus omega square L square into, this becomes actually sine omega t plus phi into cos theta minus cos omega t plus phi into sine theta, which is actually sine into omega t plus phi minus theta. So I becomes Vm by root over of r square plus L square omega square into sine omega t plus phi minus, this is theta. Theta is the tan inverse omega square L divided by r. This one is IP plus the IC part, and IC is the C into e to the power minus r by L into t, whereas this C is the constant. Now we need to find out this value of this C. Now we know that the inductance will always oppose any sudden change of the current switch. That means there was no current in the circuit before the switch was closed, so the current was 0. So hence at t is equal to 0, the I0 is always 0. So I0 equal to 0 and it becomes this one. So we can compare these two equations, and at t is equal to 0, we can put t equal to 0 over here, and here also that t is equal to 0. So C becomes Vm by root over of r square plus L square omega square, and it will be minus and into sine of phi minus tan inverse omega L divided by r. So this part is the value of C, and the overall response I is the summation of this complementary function IC plus IP, and IC is the C into e to the power minus r by L into t plus the IP, that is Vm by root over of r square plus L square omega square into sine of omega t plus phi minus tan inverse omega L divided by r. So the overall response of the system is the transient response plus the steady state response. Next, if we consider the transient response of RC circuit with the AC supply voltage. Here the series RC circuit is connected across this supply voltage, and here also this supply voltage is Vmax sine omega t, and here the switch is closed at t is equal to 0, and at when t is equal to 0, switch is closed, the supply voltage is connecting across this R and C. And at this condition, if we apply the KVL, then we can write the equation like this: Ri plus 1 by C I dt equal to Vm sine omega t plus phi. And here also we can write down the differential equation in this form, that is P plus 1 by R C into I, that is equal to omega Vm by R into cos omega t plus phi. Now here also the total response I is summation of IC plus IP, and the complementary functioning with C into e to the power minus P by RC, and IP is the Vm by root over R square plus 1 by C square omega square into sine omega t plus phi minus tan inverse 1 by omega C into R. So I becomes the IP part plus this IC part, and we know that at t is equal to 0, the capacitor acts as the short circuit. So the initial current becomes Vm divided by R into sine phi, and at t is equal to 0, the complete solution becomes the I, and whereas the C is given as the Vm divided by R into sine phi, and minus Vm divided by root over of R square plus omega C whole square into sine phi plus tan inverse 1 by omega CR. And we can substitute this C into this previous equation, so we can get the equation of I equal to e to the power minus R t by RC into Vm by R sine phi minus Vm by root over of R square plus 1 by omega C whole square and sine into phi plus tan inverse omega CR. And this part is the IC part, whereas the IP part is remain same, that is Vm divided by R square plus omega C whole square into sine of omega t plus phi minus tan inverse 1 by omega into RC. So this is the overall response, and the first part is the transient response part, and this part is the steady state response part. So next, the RL and C is connected across the voltage supply, that is sinusoidal voltage supply through this switch, and switch is closed at t is equal to 0 second. And at t is equal to 0 second, when the switch is closed, we can apply the KVL in the circuit, and it becomes the Ri plus L di dt plus 1 by C I dt is equal to Vm into sin omega t plus phi. Now, by the differentiation, we can express this term into this p square plus p into r divided by L plus 1 by L into I, that is equal to omega into Vm divided by L into cos omega t plus phi. Now we can find out the particular solution, and the IP becomes a cos omega t plus phi plus b sin omega t plus phi, and the derivative of this IP is minus a omega sin omega t plus phi plus b omega into cos omega t plus phi. Next, if we derive it once more, then IP double dash becomes minus a omega square cos omega t plus phi minus of b omega square sin omega t plus phi. Now we can substitute all this value to the previous equation, and in this equation then it becomes this equation number 14, and we can compare the left hand side and the similar terms of the right hand side. So we can find out that A is equal to B into 1 by LC minus omega square by omega r divided by L. Now we can substitute this value of A in terms of B into this equation. So we can find out the expression of B, and expression of B can we can assume that it is equal to m cos theta, whereas the expression of A is considered to be m sin theta. And after getting the value of expression of B, we can put the value of find out the value of A, and that is the this one Vm into omega 1 by Lc minus omega square by L into 1 by Lc minus omega square plus omega r by L whole square, and we can assume that this is equal to m sin theta. So if it is m sin theta, then we can say that tan theta is the ratio of m sin theta by m cos theta, and tan theta and we can find out the value of theta, and theta becomes the tan inverse 1 by r into 1 minus omega n plus 1 by omega c, and the total current IP, it becomes the this one is the A part, A into cos omega t plus phi, plus this is the B part, that is the B into sin omega t plus phi, and tan theta becomes this one, so theta becomes tan inverse minus omega L plus 1 by omega c whole divided by r, and this IP becomes m into sin omega t plus phi plus tan inverse this one, this is actually theta, and IP, that is equal to the Vm divided by m. Actually m is root over of r square plus 1 by omega c minus omega L whole square into sine of this term, and because m is the magnitude and m becomes root over of m square cos square theta plus m square sin square theta, that's why here the root over is coming. So in this way we can get the expression of IP, and for the complementary function the IC is equal to the DC response of the RLC circuit. So according to that, there will be three cases. For the case 1, that R by 2 L whole square, that is greater than 1 by LC, whereas this IC becomes e to the power alpha t into C1 into e to the power beta t plus C2 into e to the power minus beta t. Here, when the r square by 2 or r by 2 whole square is greater than 1 by LC, that means both the poles are real and unequal, and the overall response is this IC plus this is the part of the IP, that is same. So this IC is here e to the power alpha t into C1 e to the power beta t plus C2 into e to the power minus beta t, and the current response in this case is overdamped. And the next case, when the r by 2 whole square is less than 1 by LC, then we can say the P1 and P2, the both poles are complex conjugate poles, and the IC part becomes e to the power alpha t into C1 cos beta t plus C2 sin beta t, and the overall current response becomes this IC part plus the IP part, and IP part remain constant, and the current response is the underdamped or the oscillatory response. And for the last case, when R by 12 whole square is equal to 1 by LC, then the IC part becomes C1 into e to the power alpha t plus C2 into e to the power alpha t, and both the poles are here real and unequal, and the overall current response becomes this IC part is the transient part, that is C1 e to the power alpha t plus C2 e to the power alpha t plus the IP part, and the IP part is again same because it is a steady state part, and the response is critically damped. So this is the overall response of transient response of the RLC circuit when it is connected to the AC excitation. So let us take an example. Here for an example, a series RC circuit is given where the resistance value and capacitance value is given as 20 ohm and 100 microfarad, and the applied voltage is 200 sin 140, and the voltage is applied to the circuit at t is equal to 2.14 millisecond, and we need to find out the expression of the current. So here we have to keep in note that the voltage is not applied at t is equal to 0 seconds, but also it is applied at t is equal to 2.14 milliseconds. So we have to convert this 2.14 into radian. So it becomes that 2.14 into 10 to the power minus 3 into 314, that is equal to 0.672 radian. And now when the switch is closed, then we can apply the KVL, and it becomes IR plus 1 by C IDT is equal to 200 sin 314 T plus 0.67 into 2. And the overall response, current response, is the summation of the complementary function response, that is the transient response, and the steady state response IP. And IC becomes C dash e to the power minus C divided by RC. So to calculate this one, we need to find out the value of RC. R is given as 20 ohm and C is given as 100 microfarad. So 20 into 100 into 10 to the power minus 6, that gives the value of RC, and it becomes 500 e to the power. That's why 1 by RC becomes 500, because R into C is 2 into 10 to the power minus 3. So 1 by RC becomes 500. So the IC part is C dash into e to the power minus 500 T. Next, we have to find out the impedance, that is equal to 1 minus j by omega c, and by putting the values of this one, we can find out this is equal, the impedance value is 37.6 angle of 1.01. So the IP current is equal to Vm divided by this impedance into sin omega t plus phi minus this theta, and this theta is the value is equal to 1.01. So we can put the values of Vm equal to 200, because voltage is given as 200 sin omega t 140, and the Vmax is equal to 200. So here is the value of Vmax divided by the impedance, that is 37.6, that is this magnitude value into this angle. And if we put the value of this angle, then we can find out this is equal to 200 divided by this one sin 140 plus 0.672 minus this one. Now at t is equal to 0 second, the ratio of the voltage at t is equal to 2.14 millisecond to the resistance only as t is equal to 0 plus, which indicates the moment just after the switching. The switching is performed at t is equal to 2.14 millisecond, but not t is equal to 0 second. So hence t is equal to, we can assume that 0 plus means t is equal to actually 2.14 millisecond plus, because we are giving the input at 2.14 after 2.14 milliseconds. So t is equal to 0 plus, that is actually 2.14 plus, and it becomes 6.22 ampere. So if we put this value, I is equal to IC, because in case of IC it becomes e to the power C dash and C dash into e to the power minus 500 t. T becomes 0, so it becomes, the whole part will be 1, so it becomes only C plus this one, and this is becomes 5.32 in the sign of this one. So if we calculate this equation, then we can find out the value of C, that is equal to 0.93. So the response is 0.93 into e to the power minus 500 t plus, this is the steady part, that is 5.32 into sine of 140 plus 0.672 minus this 1.01. So this is the overall expression of the current. So in this video, we have considered the series RL, RC and RLC circuits with the different transient analysis of these three circuits with application of AC voltage. And These are the example and these are the references. Thank you.
Hope after this video lecture you have a clear idea about today's topic. Now we will go through some questions answer session in the context of this video lecture. Now you are requested to go through gradually and try to solve the MCQ questions by your own. Answers are also attached at the end of each question.